This is the Andromeda Galaxy. Each point represents photons that left the galaxy 2.5 million years ago, before humans existed, before we were here. I captured them from my backyard last week with a $500 telescope. And then I tried to reconstruct Andromeda's three-dimensional shape using only brightness measurements. Here's what happened. Most astronomy software shows you amazing images, but I wanted to treat my telescope as a data generation platform. Could I build something from these photons that reveal structure invisible to the eye? That's what this is about. First, I'm loading the standard astronomy libraries: Astropy for FITS images, Plotly for 3D rendering, and NumPy for the math. This loads my FITS files from the Seestar, 1100 by 1900 pixels. Brightness values range from about 765 in the background to 65,535. That's the maximum the sensor can record. The galactic core is so bright, it's actually saturating the detector. That's a huge dynamic range, way more than our eye can perceive. So here's what the raw data looks like. You can barely see anything. There is a blob in the center. This is because our eyes are logarithmic, but the camera sensors are linear. So for this reason I'm using Z-Scale, an algorithm that analyzes the pixel distribution to find optimal black and white points. Then I apply an async stretch which compresses the bright core without losing faint detail. And here's the difference. On the left, the raw data, and on the right, after stretching. Now we can see the core, the disk, even hints of some spiral structure. Same data, just reviewed. Next, downsample for performance, because otherwise my laptop would melt trying to render 2 million vertices. Then I need to normalize everything to a 0:1 scale. But here is where I make a choice that completely changes the visual. By raising the brightness to the power of 1.5, I am making bright regions dramatically brighter while compressing dim areas. This is not true in a linear sense, but it reveals the shape more clearly. I'm using Plotly instead of Matplotlib because I want this to be interactive. You can rotate, zoom in, really explore the structure. The side-by-side layout, the stretched image is on the left and it shows what the galaxy looks like. And the surface plot is on the right. It shows how I am interpreting brightness as depth. The lighting parameters here are critical. So ambient 0.3, diffuse 0.9, specular 0.3, roughness 0.5 and Fresnel 0.2. Too much specular and it will look like plastic. Too little and you will lose all depth perception. These values took honestly way too many iterations to finish. And here it is. The galactic core rises dramatically in the center, because that's where most of Andromeda's trillion stars are concentrated. And the disk extends outward, and you can see how brightness falls off with the distance from the core. From this visual you can really see the three-dimensional structure, the central peak, the gradual slope of the disk. Each point on this surface represents photons that traveled 2.5 million years through space before hitting my sensor. Ancient light, frozen in data, turned into geometry. Isn't this really truly amazing? This was just 10 minutes of exposure. I wonder what 3 hours would show. Fainter arms, deeper structure, or even more hidden patterns. There is magic everywhere we look. So, happy exploring! And if this sparked your curiosity, hit like. It helps others find it as well. See you next time!